Right now, a piece of rock smaller than a grain of sand is falling toward Earth's atmosphere at over 60,000 kilometers per hour. It will burn up in less than a second, a streak of light you might call a shooting star. But here is the stranger part. This tiny fragment is technically the same family of object that has ended entire eras of life on this planet. Somewhere between that vanishing spark and true planetary annihilation lies a whole spectrum of asteroids, each one bigger, stranger, and more capable of erasing everything you know. This is every type of asteroid that could end civilization. Start small. A near-Earth object is any asteroid whose orbit brings it. Within roughly 45 million kilometers of our planet's path around the Sun, most are harmless wanderers, rocky leftovers from the earliest days of the solar system, tumbling silently through the dark. But some of them cross Earth's orbit directly, threading through the same lane we occupy every single year. Picture a highway with no lanes, no signals, no drivers watching for traffic. That is what near-Earth space actually looks like. Astronomers track thousands of these objects, but thousands more remain uncatalogued, drifting unseen. And this is where things become strange, because the next category isn't defined by size at all. It's defined by where it hides. There is a blind spot in our sky, and it sits exactly where you'd least expect it, directly toward the Sun. Asteroids approaching from that direction are washed out by solar glare, invisible to ground-based telescopes for weeks or months at a time. An object 50 meters wide could sit inside that blind spot right now, closing the distance, and no observatory on Earth would see it coming until it was already past the point of any warning. 50 meters does not sound large, but at asteroid velocities, an object that size carries enough kinetic energy to flatten a metropolitan area in an instant. No crater required, just pressure and heat racing outward in every direction. Astronomers have a grim nickname for this class. They call them city killers. And the next one on this list is not defined by stealth, but by structure, because not every asteroid is built the same way. Rubble pile asteroids are not solid rock at all. They are loosely bound clusters of boulders, gravel, and dust, held together by nothing more than their own weak gravity, like a pile of sand hovering in space rather than a single carved stone. Some are more empty space than material, with internal porosity so high that a spacecraft could theoretically pass partway through before hitting anything solid. That looseness makes them deceptively dangerous. A rubble pile asteroid can absorb an impact by simply flexing and reforming, which means deflecting one with a single kinetic strike might not work the way engineers expect. Push on sand. Sand does not push back the same way stone does. But here is the unsettling part. Some of the largest, most threatening objects in near-Earth space are built exactly this way, and we won't know how one truly behaves under force until a mission actually tests it. Contrast that with metallic asteroids, dense fragments, believed to be the exposed cores of shattered protoplanets from the solar system's violent infancy. These are not loose gravel. They are solid nickel and iron, some with densities several times greater than ordinary rock. Take a rubble pile of the same physical size, replace it with solid metal instead, and you get an object that hits with dramatically more force per square meter, punching through atmosphere with far less resistance, far less burning away. A metallic asteroid just a few dozen meters across can still reach the ground largely intact, delivering energy equivalent to a large conventional explosion concentrated into a single, silent instant. And the next entry on this list changes the danger completely, because it isn't one object anymore. It's two. Binary asteroid systems consist of two bodies orbiting a shared center of gravity, a smaller moonlet circling a larger primary, locked together across empty space, Roughly 1 in every 6 near-Earth asteroids is now believed to belong to a system like this, far more common than early observations ever suggested. If you've made it this far into the asteroid catalog, drop a like right now, because the next class on this list doesn't just threaten Earth directly. It hides in plain sight along one of the busiest orbital paths in the entire solar system. Binary systems complicate every defense strategy we have. Deflect the primary, and the moonlet's own gravity may pull it right back off course. 2 objects, 1 shared fate, and twice the uncertainty for anyone trying to calculate where they'll end up. Trojan asteroids take a different kind of hiding spot entirely. These are objects trapped in stable gravitational pockets, 60 degrees ahead of or behind a planet in its orbit, riding along like silent passengers rather than crossing paths directly. Jupiter alone shepherds hundreds of thousands of them, but Earth has Trojans too, asteroids that have apparently shared our orbital lane around the Sun for an unknown length of time, invisible against the glare and distance until recent detection efforts finally caught one. A rock could be riding alongside our planet right now, less than 100 million kilometers away, and we would have no way of knowing unless we happened to look in exactly the right direction at exactly the right moment. Nobody knows how many more are out there, and nobody may ever know until instruments powerful enough to separate that faint light from the sun's overwhelming glow finally come online. So what happens when an asteroid isn't just crossing Earth's orbit, but actively classified as a threat? That's where potentially hazardous asteroids come in, a formal designation reserved for objects large enough and close enough that even a small gravitational nudge over time could shift their path into a collision course. The classification itself is a kind of warning label applied to any body over roughly 140 meters wide that comes within about 7.5 million kilometers of Earth's orbit. That distance sounds enormous. In cosmic terms, it is nothing, a rounding error on the scale of the solar system. Thousands of objects currently carry this designation, and every year new ones join the list. The next asteroid on this catalog, though, does not arrive from our own solar neighborhood at all. It arrives from somewhere else entirely. Interstellar objects are asteroids or comet-like bodies that formed around another star system altogether, ejected into the galaxy long ago, drifting for millions or even billions of years, before ever crossing paths with our Sun. We have only confirmed a small handful of these visitors passing through our solar system, moving on hyperbolic trajectories so extreme that they will never return, exiting as fast as they arrived. Take an ordinary asteroid, born from our own solar disk, and compare it to a body that formed light years away under a completely different star, and you get an object whose composition, structure, and history we barely understand at all. No shared origin, no predictable orbit, no established models. Just a stranger passing through, glimpsed for weeks before vanishing back into the dark forever. And that leaves us with the final classification, the one every earlier entry on this list has been building toward. A planet-killer asteroid is generally defined as any object over roughly 1 kilometer wide, large enough that a collision would inject enough dust and debris into the upper atmosphere to disrupt sunlight and agriculture on a global scale, not just regionally, but everywhere at once, for years afterward. Objects this large are the rarest class of near-Earth asteroid, and thankfully, the ones large enough to end civilization outright have been tracked with far greater confidence than their smaller, sneakier cousins. But confidence is not certainty. Somewhere in the deep dark, beyond current detection limits, there could still be a body this size that current surveys have simply never seen, drifting on a slow, silent, million-year orbit that eventually, someday, brings it home. That is the full ladder from a vanishing streak of dust to a kilometer-wide object capable of reshaping the climate of an entire world. Every category on this list exists somewhere out there right now, tracked or untracked, cataloged or invisible, tracing its own quiet path through the solar system, while life on Earth carries on beneath it. If this kind of cosmic catalog fascinates you as much as it unsettles you, subscribe before the next object on the watch list gets a little too close. And if you're not ready to leave near-Earth space just yet, there's a full playlist waiting for you, exploring everything else drifting silently through the dark.